This is a video for exam 1, number 10. Number 10 says, let f of, or just let f, going to make the pen a little larger here. Let f be defined as follows. Where a does not equal 0. Okay, f is defined in the following way. In other words, it says f of x is equal to, it's a piecewise defined function, it's equal to x squared minus a squared over x minus a whenever x does not equal a, and it's equal to 0 whenever x does equal a. So we have two rules for two different situations. The first situation is that it's any value of x other than a. We use this rule. And if x equals a, at that single point where x equals a, then we say the function just becomes 0. Now it asks us, which of the following are true? Which of the following are true? This type of question is not the same as a multiple choice question. I'm not asking of these which is the single one that is correct. It's really any of them could be true, and we have to decide which of them are true. So the first possibility, first of all, is this true? Is the limit as x goes to a, does the limit as x goes to a of f of x exist? So let's consider this. What does it mean for the limit as x approaches a of f of x to exist? Well, keep in mind that the limit of a function doesn't actually depend upon what is going on right there at that value. It has to do with what's happening to that function as you get really, really close to that value. So to answer this question, we can actually look at the first rule. This rule includes values of x that are to the left of a and to the right of a. So we can think about the left-sided limit and the right-sided limit. They have to be the same in order to get regular limit. So let's see if this exists by actually trying to determine what it might be. So let's think about the limit as x approaches a of x squared minus a squared over x minus a. Well, you see this numerator is a difference of perfect squares, so this can be written as x, the quantity x plus a, times the quantity x minus a. This whole thing is over x minus a. And we see some factors that can be canceled out. We can cancel the factor from the top and the bottom. And this is the limit as x approaches a of x plus a. And originally we couldn't get away with just substituting an a in there, because it would make the expression become undefined, which is not okay. But as we have simplified and rewritten this limit, there's now no reason that we can't substitute that a into this value of x, and we end up with a plus a, which is 2a. Certainly 2a, whatever a happens to be, is a quantity that exists. We have found this limit, and so we will say yes, this first possibility is one of them that is true. Let's think about possibility 2. Is possibility 2 true? Possibility 2 says f of a exists. Well, if you understand what it's asking for, this should be one of the easier ones to decide that it is true. See, what is this saying? It means, is there some value for f of a? Is f of a undefined, or is there some value for it? Well, look back at the definition for f of x. It's this piecewise defined function. And look at what it says the function becomes when x equals a. I'm going to switch colors here so I can highlight this. Look at what it says the function is equal to when x equals a. It says it's equal to 0. So, as a matter of fact, we can confidently say that this is true. Yes, it does exist, because we know what it is. When x equals a, f of a equals 0. No problem. It says so. Now let's look at possibility 3. Possibility 3 says f of x is continuous at x equals a. Alright, well, let's think about that. I suppose in order to do this, you need to know what does it mean for a function to be continuous at a certain point. Well, what it means for a function to be continuous at that point is that the limit as x approaches that point for that function should be equal to the value you get when you just evaluate the function at that point. So, for one thing that should be clear is that f of a can't be undefined. If the left-hand side comes to something, then certainly it has to be something that's not undefined. So f of a must exist. We've already said that it is. But we've done a lot of this work. On the left-hand side, that was what we figured out in statement number 1. We said we actually did the work, and we found that the limit as x approaches a of f of x was 2a. Now, does this equal the value of f of a itself? Well, the value of f of a itself, we decided, was 0, because that's what it says. Well, does 2a equal 0? We can say no. And the reason we can say no is because of this little fact that they gave us in the original problem right here. There was this little fact that they gave us where they told us that a does not equal 0. That was a nice and important thing for them to tell us. So this lets us reject this as a possibility. Since a does not equal 0, there's no way for 2a to equal 0. So this is not true. And the best answer to this question is to say that 1 and 2 are true.